Hi, I'm David. There's several diagnostic trouble codes that are associated with a mass airflow or MAF sensor. In this diagnostic module, we'll look at P0101 and a P0104 signal performance DTCs. The MAF sensor sends information to the engine control module, or ECM, about the amount of air entering the engine. This can be an analog signal via a changing voltage or a digital signal via a changing frequency. The voltage or frequency produced by the MAF sensor changes as the rate of airflow changes. This information makes it possible for the ECM to maintain the required air-fuel ratio and to compensate for variations in atmospheric pressure. If you have any MAF sensor DTCs and a no-start situation, disconnect the MAF sensor and try starting the engine. If it starts under these conditions, then the fault is probably the sensor itself. This is a typical MAF sensor circuit. There is a 12-volt supply coming from the fuse box, a ground or low reference, in this case coming from the engine control module, and the signal wire. A P0101 or P0104 are signal performance DTCs. The signal to the ECM is within set parameters programmed into the ECM. If the ECM detects that the signal does not match other parameters it's looking at, a performance DTC will set. These DTCs can be caused by many things, some electrical and some mechanical, and are often accompanied by a customer complaint of poor performance. Your preliminary investigation should include checking that the sensor wiring is not routed too close to any electromagnetic fields or high current wiring. Also, check there is no contamination of the sensor. Modifications to the air induction system or the fitting of aftermarket air filters may also set these DTCs. If you have access to a scan tool, then you can have a look at the MAF signal information. Compare the idle reading to specifications, then accelerate the engine slowly while observing the parameter. You'll be looking for any sudden changes in the signal that are not consistent with the throttle opening. Check all the vacuum lines on the engine for leaks. The quickest way to do this is using a leak detector. Make sure there are no air leaks between the MAF sensor and the throttle body, and that there are no blocked or collapsed intake tubes. Don't forget the intercooler and hoses on a turbocharged engine. Check for a restricted air filter element and any restriction or carbon buildup in the throttle butterfly. An unsealed oil dipstick or a loose or missing oil filler cap can also cause a P0101 or a P0104 to set. While checking the dipstick, also check the oil level, as an overfilled crankcase may be the cause. If any of these conditions are found, rectify them and then recheck for the fault. If none of these faults are evident, you'll need to carry out the following electrical procedure. First, check for the ground supply to the MAF sensor. Remember to check battery voltage first so that you have a reference to compare your readings to. Disconnect the sensor and, using a voltmeter, measure the voltage between the ground terminal of the harness and battery positive. You should have close to battery voltage. If the reading is correct, don't forget to do a wiggle test while watching the meter, as these are poor performance or intermittent DTCs. If the voltage is low, this would indicate a resistance in the circuit. Check any connectors in the circuit for corrosion and the correct terminal tension. If the circuit goes to a vehicle ground, then test this point to battery positive. If the reading is now correct, then the resistance will be between the ground point and the sensor connector. Otherwise, it will be the ground connection itself. On systems that get a ground from the module, it will be necessary to backprobe the module connector to determine where the fault is located. If the voltage is still low, then the module connector or the module itself will be the cause. An acceptable reading would indicate that there's a problem between the module connector and the sensor connector. Terminal tension and corrosion of the connector need to be checked. If the connector is okay, the module or its ground connections will be at fault. Check all the module grounds before condemning the module. The MAF sensor supply voltage will need to be checked if there is no fault in the ground circuit. Connect a voltmeter between the harness connector 12-volt supply and battery ground. You should get close to battery voltage. If the reading is correct, don't forget to do a wiggle test while watching the meter, as these DTCs are poor performance or intermittent faults. A low voltage will indicate a resistance in the supply to the sensor. It's now a matter of checking the voltage back along the circuit to find the fault. If the ground and supply voltage are correct, you can now test the signal wire. With the ignition on, you can measure the voltage between the signal terminal at the sensor connector and ground. The reading should be between 4.8 and 5.2 volts. Don't forget to do a wiggle test while watching the meter if the reading is correct. Again, a low reading would indicate a resistance which would be checked by following the circuit back to the module. If the voltage at the module connector is still low, then the module connector or the module itself will be the cause. An acceptable reading will indicate a problem between the module connector and the sensor connector. Another test can be performed on the signal wire. If the mass airflow sensor produces an analog signal, the signal wire can be shorted to ground while observing the scan tool. The voltage should go from 5 volts to 0 volts. This indicates that the module is receiving the correct information. If the signal wire has tested okay, but this test fails, then the fault is most likely in the module. Some mass airflow sensors use a changing frequency for their signal. To test these systems, you need access to a signal generator. Apply a signal of 5 kHz at a voltage of 5 volts and observe the scan tool parameter. The scan tool should indicate 5 kHz. If this is not the case and the signal wire has tested okay, then the module will be at fault. If all the wiring tests okay, reconnect the sensor and start the engine. Perform one final wiggle test of the harness and all the connectors while watching the scan tool parameter. If a fault can't be found, the sensor is the most likely cause of the DTCs. There you have the diagnosis of P0101 and P0104. Make sure you check all areas of concern. Don't assume that things are correct. Test them. And as with all DTCs, once you've found the fault, clear the codes, take it on the appropriate drive cycle and retest. And remember, training is the key to your success. Bye for now.